I was just looking in the bottom of the Headstock gearbox to take a decision whether I need to flush it with kerosene. This stuff here is quite sticky. Whether it is more similarly done further down there, I don't know. But then I was looking at it and I saw down there something interesting. Looks to me like a dowel. Whether that's part of the gearbox that has fallen off, I hope not. I certainly didn't drop it down there. Right, well, I'll just see if I can retrieve this pin or dowel or whatever it is that's down here. I might have it in here. Let's see. Did I get it? Yes, I got it. Right. What is that? Well, I think that is the end of a taper pin that has sheared off. I don't know if you can see that side of it is sheared. In fact, this pin was down here. You see there is a pin there in this that controls this lever. It goes into notches, and another one here and a similar one on this side. And I think I think possibly this pin was replaced at some stage. It was driven in too far, so part of it stuck out the other side of this shaft, and then when people moved it, that part got sheared off and fell down there. That's my theory. I'm happy with that situation. Well, I've got 5,000 litres of kerosene because I have oil central heating. I thought I'd start by just putting about an inch of kerosene in the bottom of this and switching it around with a view to getting any stuff that is settled on the bottom out. Any muck, I mean. Sludge is the word I'm searching for. This is horrid stuff, kerosene really, isn't it? I've got a bit of electric flex here which I'm going to use to kind of stir things up. I can get it going down there quite well with this. Right. I think that's been in there long enough. Out of that. Well, it's not particularly dirty, but not completely clean either. So it seems to have achieved something. Right, I'm just going to kind of give a bit of a clean to these channels here. Well, we don't want kerosene all over everything, do we? So I mean, this is cleaning it as best I can without actually disassembling it, which I really don't want to do. So we'll get the stuff off these shafts. Etc. And I'm going to fill it up to the sight line, assuming nothing comes out from anywhere else, assuming it doesn't obviously leak. I've already spilt it all over the place. I should quite like to know if there's any obvious leaks anyway. Just short of the recommended oil level. Right, so I've got it up to the recommended oil level, and I still haven't got power on this thing, but I can drive it backwards, I think, like this. Put this in the right. I think that's the easiest one. I don't think there are any gear. All the gears are actually being turned, aren't they? I wonder if I can do this. Whoa. So maybe if I put the lid on. Back is running down. That doesn't help much. It's harder to turn like that because it's a slow speed. It's pretty damn clean anyway, isn't it? So I don't reckon I've done my job there. I don't want to leave the kerosene in too long because I think it attacks some kinds of rubber oil seals. Not quite sure what. That's the magnet on the bottom, which has collected a little bit more stuff since I flushed it. It doesn't totally drain. There's a few puddles at the bottom. So I think I'll stuff some tissues down there and just absorb that. That's good. Still producing some kind of muck, Nevertheless, I think it's pretty good. This is Castrol AWS 68. It's about 900 millilitres in here. We'll see how much it takes to get up to the cyclone. That was 900 millilitres. Right, another 840 millilitres in here. It's supposed to take a litre, so I'm just going to give it a little bit. Right, that is up to the site level. And we have 250, 60, 70, about 280 millilitres left. So it took 1.46 litres, whereas the manual says it should take 1 litre. But we go by the sight glass, not by the manual. Right, I'll give that a bit of a whirl. Alright, we'll put it on the right setting. Well, I'm spraying oil all over the place, rather unnecessarily. Perhaps I should put the top on again. So, I should probably drain that oil tomorrow and then refit it again. And that will be the job done, I think. It's interesting that after running it for a while with the lid on, this area here has got oil in, but this area has not got any oil in. So if it needs oil dripping down there, it's probably not going to happen, or maybe it happens under different gear settings. Maybe if I run it like that, we can see how it's splashing. Nothing splashing over there, that's my point. Nothing moves that, does it? The only thing that would splash more there is if this moved over there, but it doesn't. So my point is, if you need lubrication in the headstock, bearings to come down through that. It's not going to do it. However, I dare say there's a fair amount going around on this shaft anyway. Anyway, it's not my role to redesign this headstock. It seems to have lasted for 35 years without any trouble, so we'll give it the benefit of the doubt. Well, I drove the headstock with this in place just to get the oil going all over the place. Then I left it for 24 hours, and I'm just wanting to see how it appears to be leaking. Possibly from that round, the bottom of that round red cap, and definitely here. From the big red thing round the spindle, but only at the flange. It's not leaking here, it's leaking from this bolt or this seal on this flange, I think. Well, I was just looking at the parts diagram to try and see how the back end of the spindle is constructed. It comes shown here. The first thing here is a bearing, which I found it's still available. It only costs £743.91. And interestingly, the photo there doesn't seem to match the drawing. But anyway, I have no intention of replacing the bearing because the bearing seems to be perfectly okay. Then the next thing is this collar, screwed collar, which pulls the spindle towards the back and thereby applies pressure on this taper roller bearing. And then we have this red thing where I observed the leak, and it seemed to be leaking from round here. This is a joint washer. This is just a solid red metal thing, and it doesn't show any oil seal anywhere here, so I assume that this red metal thing is or incorporates a labyrinth type oil seal. So I think I could remove this, it's only held in by 3 M5 bolts, without in any way affecting the alignment of the spindle. And then I could maybe replace the joint washer or put some sealing compound on it, put some thread sealant on these bolts if they go straight through, and see if make sure that any drainage holes are unblocked, and see if that gets rid of the problem. I think this thing is just something stuck on the end of the spindle. I'm not sure whether it's something to do with the collet closer that I had on here, but whatever it is, it's got to come off. Well, there are 4 grub screws here, and 3 of them come off and 1 of them won't. That's typical, and it just rotates in this 3mm Allen key. So I'm going to just see if I can shock it a bit. Just kind of knocking down the top of the screw anyway. Yeah, it's actually knocked it down quite a long way, so now I can't get this thing in. Well, the correct Allen key, 3mm, is still spinning round, so I've put this one in, which is an imperial one, which is, I think, 3.13mm, 9/64 or something like that. But that's not going to give up easily either. I think, because I'm reluctant to put a blow lamp on this, I'm just going to put some penetrating oil in here and leave it overnight. That's the only gentle thing I can do. Well, it's the next morning and I haven't been able to get this loose, but I've discovered that this thing will come off anyway. So now I can, I think all of this is above the fluid level, the oil level, so I should be able to just take it out. I might be able to put a blade in there. That's it. Still, it's a strong thing. Right, let's have a look at that. Right, so that's the ball taper roller bearing, and that's the collar that adjusts its preload. And these grooves prevent oil from wicking along here and cause it to go down into this labyrinth oil seal, which we'll just look at in a minute. So there's nothing wrong with that except a little bit of surface rust. That's the bottom side of it. I'm thinking that if I just clean this up and put a little Hylamar on the joint washer, the leaking problem should go away. I'm just wondering how much oil gets onto this bearing just by splashing along there, and or whether it needs oil coming down from the top through that hole that I showed before. I'm just going to drive it with the lid on the headstock and see. Well, I wouldn't say there was exactly a vast amount of oil coming through here, or indeed any to speak of. Right, so the lid is on, it's full of oil. If I just dry this all the way around, like that, and then we drive the spindle forward. The question is, how much oil has come through here now? So my finger is dry. A little. I wouldn't say it's exactly flowing free with lubrication. Not much getting through there. Yet we know that it is splashing all over the place inside. So, I mean, there's nothing getting onto here. Not that this needs to be lubricated, but I mean, if oil was passing through there, it's got to come out somewhere, hasn't it? So we know oil is splashing all over that, and there's plenty of oil in here, and there's nothing to stop it going down there if it wants to, and there's plenty of oil at this level on the main shaft, so I suppose it should go through there, but well, I don't know. But it's all according to the book. That's all I can say. Personally, I think more oil should come through that bearing. On the other hand, quite a lot of oil has ended up down here, so I guess it must be coming through in reasonable quantities. Right, well, this joint washer is okay. Well, it's probably quite hard, but I mean, I think if I just clean it up and put some Hylamar on both sides of it, it should be all right. It's typical of joint washers that always with a joint washer, the bit that needs to be oil tight turns out to be the thinnest, the narrowest part. It's just this part round here that needs to be oil tight. So we've got the labyrinth seal here, and that is the drain for the labyrinth seal, which appears to have a piece of swarf in there. See if I can get that out. Or is it in fact intended to be in there? I don't think that's intended to be in there. Doesn't look sensible to me. There's one bit. There's another two bits. They would not have, that would not have blocked that hole, but it's a bad sign so far as you shouldn't have chunks of metal in your labyrinth seal, should you? Quite small, but they shouldn't be there. And then we've got some gunge that has accumulated here. That gunge, which I don't think is metallic, so we'll just clean that up and refit it and hope for the best. Right, I'll clean that up. This is made of aluminium, by the way. Well, I think oil is just draining off the spindle and out of this bearing. So I'm just going to let it go on draining until it stops. And then I will refit the joint washer with some Hylamar. Alright, I made another joint washer in the end, because I thought that the original one had been squashed quite a lot. And I thought that I'd rather fit it dry than have Hylamar all over it, which would cause a problem next time I take it off. Well, that's a drain hole to drain the oil back into the case of the headstock, and that's another one. That's some mounting hole for some external gear, and those are the 4 bolts that hold this on. Oh, I think that should do it. Right, well, it's next morning and there's no oil leaking from that part of the headstock, so that seems to have fixed that problem. But whilst I was editing this video, I saw the sort of close-ups of me turning the spindle by hand and looking at the rear spindle bearing, and I thought it looked rather odd. The taper roller bearings that I'm used to be, the rollers were tightly spaced together, whereas these are separated by quite a large distance. I just noticed that the rollers were rolling back under their own weight as soon as the spindle stopped moving. And I thought, well, surely that wouldn't happen if there was an adequate preload on this taper roller bearing. So I previously tested the spindle to make sure it had no movement in at right angles to its axis, and I went back and I tested the end float as specified by Harrison, and it's supposed to be less than 5 microns. It's actually less than 2 microns. So they're saying that if the end float is less than 5 microns and you can still turn the spindle, it's okay. So presumably it's okay, but it looks odd to me. What do you think?